Yo, this is Mr. O. Yo, this is Mr. O. And today we're going to go over some of the examples and practices. Right, so we're given here f of x equal to 2 over x plus 4, where it's a rational function. The degree of the numerator here is 0. The degree of the denominator is 1. Since the top is lighter or the bottom is heavier, we can say that the horizontal asymptote is y is equal to 0. And for us to know the vertical asymptote, we look at the denominator side, and we know that x plus 4 is equal to 0 by solving for the x. Minus 4 minus 4, x equal to negative 4, and that's your vertical asymptote, x is equal to negative 4. For us to find the x-intercept, we look at the numerator and see, in this case here, there's no value of x on the numerator, so we can say that there will be no x-intercept, okay? Or another reason for that is that the horizontal asymptote is the y equals 0, which is the x-axis. So therefore, there should be no point along that dotted line. So there should be no x-intercept there. So this is your y equals 0. Your x negative 4 is right over here. Make sure you label your graph all the time. Nothing here can be canceled, so we can say that on our whole will be none also. For us to find the y-intercept, we make the value of x equal to 0. So f of 0 is equal to 2 over 0 plus 4. 0 plus 4 is 4, so this will be 2 over 4, or it's going to be 1 half. The y-intercept here is 0, comma 1 half. 0, 1 half right here, approximately. Now we can graph it, and I suggest to draw a table here, wherein the middle number ideally will be your vertical asymptote, so x, y, and let's say this is the negative 4, that's your vertical asymptote. So you can pick 2 to the left or to the right. I can pick negative 3 and negative 2 here. The other way around, sorry. Negative 5 and negative 6, and negative 3, and let's say negative 1. Okay? You would need to use your calculator or plug in the x values on the function. So f of negative 6 is 2 negative 6 plus 4. That will give you 2 over negative 2, or just negative 1. F of negative 5 is 2 over negative 5 plus 4, which will be 2 over negative 1, or it will be negative 2. F of, this will be nothing there because it's asymptote. F of negative 3 is going to be 2 over negative 3 plus 4, which is 2 over 1, so this will be 2. And f of negative 1, 2 over negative 1 plus 4 is going to be 2 over 3, or 2/3. So now we're going to plot the points. Negative 6, negative 1 right down here, negative 5, negative 2, negative 4 is there, negative 3, positive 2, negative 1, 2/3, and there you go. You know the graph will get closer to the asymptote, so this gets closer to the asymptote, this gets closer to the asymptote, and you connect them. Smooth curve. This gets closer to the asymptote, this gets closer to the asymptote, and you connect them. And to check if our answer is right, you can see it matches the answer over here. So we're all good here, okay? Next, number 2, f of x is equal to 3x squared minus 9x. divided by x cubed minus 7x squared plus 12x. So in this case here, you should check the simplify first by factoring, find the GCF, all the methods in factoring. So first in the beginning on top, I have a degree of second. The degree on the bottom there is third. So I know the bottom is heavier again. So my horizontal asymptote there is y is equal to 0. Number two, I know I can factor this further. The top portion, the common factor is 3x. So this would be x minus 3. And the bottom one there will be common there is x. I factor out the x first outside. This will be x squared minus 7x plus 12. And you can still factor this further. That will give you x, x, 4, and 3, negative, negative. Okay? So the factors of this one here would be an x outside, x minus 3, and x minus 4. Although you can tell that after you factor them all, you can simplify by, you can cancel several things here. First, you can cancel this x's here. That means you're going to have a whole at 0. Why 0? Because x is canceled, so set it equal to 0. X divided by itself, 0. We're going to know the missing y coordinate in a while, okay? Then we're going to cancel this also here because they're the same. So we know we have another whole, x minus 3 equals 0. So add 3 on both sides, x equal to 3. So these 3 comma blank. Okay. So what's left with us, we call it FF or factored form. It will be 3 over x minus 4. That is the functions going to be left for us because the x and the x minus 3 were cancelled. Again, you can tell the vertical asymptote from the denominator of the factored form. It's going to be at x minus 4 is equal to 0. Add 4 on both sides. So you know x equal to 4. Let's complete the whole. So what we're gonna do, we're gonna plug in the 0 to the remaining problem or remaining factored form. So this will be now f of 0, 3, 0 minus 4. We know that will be 3 over negative 4. So this will be negative 3/4. And the other one is f of 3, 3 minus 4, which is 3 over negative 1 is negative 3. Now, for us to find the x-intercept, we look at the numerator. It so happened that y is equal to 0 for our horizontal asymptote. There should be no graph right here. So if there's no graph there, that means there should be no x-intercept. How do we find the y-intercept? We're going to put 0 on the x value. Since we know that if you plug in 0 here, that is the same thing as the whole there. That means there should be no y-intercept because it will be the whole. It will be, if you plug in the 0 right here, it will become 3 over 0 minus 4, which is 3 over negative 4, which will be the same thing as that one. Unfortunately, it says here on top, it was the whole. So basically, there should be no y-intercept here because the y-intercept happened to be also your whole. So let's plot the points here now by drawing the vertical and horizontal asymptote. Y equals 0 is your horizontal. For the vertical, you have 4. And then you're going to have a hole at 0, negative 3/4, somewhere right here. And you have 3, negative 3, 1, 2, 3, negative 3 right here. Those two are the hole. You can tell already that this will be get closer to the asymptote. This get closer to the asymptote. And you can connect this to here. Okay? And then the right side, remember, or if you don't like to do it that way, you can draw a table, x, y. So you know the asymptote there, the vertical is 4. So if I pick a one number on the left, let's say let's pick 2 there, and then let's pick 5 and 6, so there should be nothing here. You're gonna plug in f of 2 to the factored form, so 3 over 2 minus 4. That will give you 3 over negative 2, or negative 3 halves, or 1.5. So this is roughly negative 1.5, which it is. And then for the 5, 3 over 5 minus 4, which is 3 over 1. So that's going to be 3, 5, 3, 5, 1, 2, 3, right, on this purple point. And last one here is 3 over 6 minus 4, which is 3, 2, 1.5 here. So 1.5 for 6 right here. So this gets closer to the asymptote, this gets closer to the asymptote, disconnect them. And we can tell that the graph matches this one here. There should be a hole right here. There you go. Another thing I would like to add here is the domain. The domain here is from here. I'm gonna highlight it so you can see from negative infinity is stop there. So from negative infinity up to this 0 union, then it continue from 0 up to here, which is 0 to 3 union, then it continues further from 3 right here to the asymptote 3 to the 4 union to continues further up here, no holes there, so that means from 4 to infinity. All right, next. 2x minus 8 over x minus 2. We know the factored form here is 2x minus 4, and this is x minus 2. You can tell that there's nothing we can cancel, so there should be no holes for this problem. No holes. We can tell that the degree of the numerator is 1. The degree of the denominator is also 1. So therefore, your horizontal asymptote will be y is equal to 2. Where do you get a 2? Because the leading coefficient here is 2. The leading coefficient is 1. What's 2 divided by 1? That's going to be y is equal to 2. The vertical asymptote will be coming from your denominator, which is here. X minus 2 is equal to 0. Add 2 on both sides. X is equal to 2. Your x-intercept is based on your numerator. So 2x minus 8 is equal to 0. Solve for the x here. Add 8, add 8. 2x equal to 8. Divide by 2, divide by 2. X equal to 4. So therefore, the x-intercept here should be 4, comma 0. The y-intercept here, you're going to plug in the 0 to the x. So this would be 2 times 0 minus 8, 0 minus 2. 2 times 0 is 0 minus 8. 0 minus 2 is negative 2. This will be 4. So 0, comma 4. What next we need to do is we try to graph them. Y equals 2. X equals 2. Those are your asymptote. This is your x equals 2, y equals 2. You plot the points for 0, so this is for 0, and y-intercept 0, 4, 0, 4. You don't have a hole, so this time we have to draw a table. X, Y. We know the asymptote is at 2. Then there's nothing there. Pick 2 points on the left. Let's say I have a 1 and negative 1 there. And let's pick here 3 and a 5. So we plug in the negative 1. You can plug in the negative 1 to the factored form or to the original problems. So f of negative 1, 2 times negative 1 minus 8 over negative 1 minus 2. That will give you negative 2 minus negative 8, negative 3, which is negative 10 over negative 3, or 10 thirds. Next, we're going to plug in the 1. F of 1 is 2 times 1 minus 8. 1 minus 2, that will give you 2 minus 8, negative 1, or negative 6 over negative 1, or just 6 here. Now you plug in the 3 now. F of 3, 2 times 3 minus 8, 3 minus 2, 6 minus 8. This is negative 2 over 1. This will be negative 2. And the last one, F of 5, 2 times 5 minus 8 over 5 minus 2, 10 minus 8 over 3, which is 2 over 3. This is 2 thirds. Let's plot it now. 1, 6. Negative 1, 10 thirds. 10 thirds is approximately 3.3. So negative 1, 3.3 right here. Right side 3, negative 2, 3, negative 2, 5, 2 thirds, a little bit over the x-axis. So you can already tell the graph, this gets closer to the asymptote, this gets closer to the asymptote here, and just simply connect them. This gets closer to the asymptote, this gets closer to the asymptote, and just simply connect them. And that's the graph, there you go. And let's find the domain. The domain here, you can tell it's starting from here, going that way. So start from the left, negative infinity, up to your 2, union, and then it continues from 2 to the right, 2 to the infinity. And that is your domain there, okay? So you know that you have a 0 degree here and a 2 here. That means the top is lighter or the bottom is heavy, so the horizontal asymptote is y is equal to 0. You know you can factor the bottom as common as GCF is x, x minus 3, and you cannot cancel anything right here. So there's no hole here, no hole. You know that there's the horizontal asymptote is y equals 0, and at the same time, there's no x in the numerator, so there should be no x intercept. And if you put 0 on the x's, 3, 0 squared minus 3 times 0, you know it will be 3 over 0, which will be undefined. That means you're saying that there should be no y-intercept also. And what else? The VA is based on your denominator. There are two factors here. One is x, set it equals 0, and the other one is x minus 3 equals 0. You know that is already isolated, so the vertical asymptote is x equals 0. X minus 3, you add 3 on both sides, so x equals 3. So x equal to 3. Now we can graph the problem. So 0 for the horizontal will be right, this pink equation. Is the y equals 0. X equals 0 is right here. And x equals 3 will be right here. So what do we do now? We're gonna find tables. We're gonna draw a table here. This will be a much longer table because we have several vertical asymptotes. So x and y. So we know that the middle one here is 0. Let's cross out, and let's do 3 points here. And let's say this is the 3. There's nothing there. Okay. All right. So on the left side 0. Let's say we pick -1 and -2. So we're going to plug into the equation. So 3 over negative 2 squared minus 3 times negative 2. That will give us 3 over 4 plus 6. That gives us 3 over 10. So zero point 0.3 here, right? And then for the negative 1, 3 over negative 1 squared minus 3 times negative 1. This will be 3 over 1 plus 3. So that will be 3 over 4 or 0.75 or 3 fourths. On the right side of 0, I'll pick all the points there. It even might be a fraction. So I pick one. I pick here 1, 1.5, and I might pick also a 2 there. Okay. A 1, so 3 over 1 squared minus 3 times 1. So 3, 1 minus 3, or 3 over negative 2, or negative 1.5. Again, you can use calculator at this time. If you're not sure with your arithmetic, with your negative sign, you may use calculator. 1.5, 3 over 1.5 squared minus 3 times 1.5. Okay, in this case, I'm going to use a calculator also. 1.5 squared minus 3 times 1.5. Then 3 divided by the answer. This will become negative 1.3. Repeating. And next will be 2. 2 squared minus 3 times 2. 3 over 4 minus 6, or 3 over negative 2, negative 1.5 again. Okay. Then you continue the table on the right side, somewhere here for this area. So that will become another table x, y, 4, and let's say 5 there. So we're going to plug in the 4. 3 over 4 squared minus 3 times 4. 3 over 16 minus 12, or 3 fourths, for 0.75. 3 over 5 squared minus 3 times 5. 325 minus 15, or 3 over 10, which is going to be 0.3 again. Now let's plot our graph here. Negative 2, 0.3. 0.3 is a little above the x-axis. Negative 1, a little bit over the, not over, a little above the x-axis still. And you know that this will be connected towards the, getting closer and asymptote, and then connected. Now, this is a tricky part. Look at the green one. They both have negative 1.5. Means say they become parabola here. Okay. At 1, go to negative 1.5, write this. At 2, become also negative 1.5. But at 1.5 becomes negative 1.8, is a little bit above that. So you can tell that the graph gets closer to the asymptote, get closer to the asymptote, and then make your U shape, or the parabola. Next one there, the bottom part, on the right side, 4.75 above it, and 5 above. If you notice, these two here are very symmetrical. That's why the graph here goes something like, get closer to the asymptote, get closer to the asymptote there. And for our domain here, the domain is from negative infinity up to 0, union 0 to 3, union 3 to the infinity. And there you have it. We answered 4 problems in solving or graphing rational function together with its characteristics. I hope you learned something, and as always, kaboom.